For Unit 5, Day 3 notes is talking about congruent figures. And so for our purposes, figures could be just our shapes, different shapes. And we're not going to always talk about triangles for this lesson. We could talk about quadrilaterals, which are four-sided shapes. We could talk about triangles, pentagons, hexagons, any shapes that we have dealt with in the past or we will deal with in the future, we can talk about in Day 3. So for example 1, finding congruent parts. We're going to refer back up to this box here, key concept. So congruent polygons have congruent corresponding parts. Their sides and their angles. So they're saying that like this AD, segment AD, would match up to segment EF. Okay? Or angle A would match up to angle E. When you name congruent polygons, you must list corresponding vertices in the same order. Okay, so a few things. This right here is called congruent statement. And you will see many times that we will go back and refer to the congruent statement. It's very important. Now, this particular figure here, the polygon has been like flipped over. Okay, so I know like, okay, B goes with F, C goes with G, etc. But let's say like the figure wasn't flipped, it was like rotated around and you couldn't match it up very easily. All you do is you look at the congruent statement. So if A is first, that means it's congruent to the first letter here, E. So A and E match up. Okay, so B has to match up to F since they're both the second letter. Okay. Then if you were to look at like segments, and you have segment AB. So here's segment AB. It has to match up to the first two letters here, EF. So here's EF. We can see they do match up. They are congruent to each other. Okay, so this congruent statement is a big deal. It is very helpful in many situations. So going down here, in example 1, it says, if HIJK is congruent to LMNO, what are the congruent corresponding parts? So HI, I could try to figure out over here what it is congruent to. It looks like LM to me. But if I go to HI right here, it's the first two letters. LM is the first two letters. Has to be LM. So HI is congruent to LM. And then we had IJ. So here's IJ in the middle. And that has to be congruent to MN. And yes, of course, you could look at the picture, the images there, and try to figure this out. It also is much easier just to look at the letters up here, the congruent statement. So JK is congruent to NO. And then lastly, we have K to H, so O to L. Okay, so KH is congruent to OL. Okay, and then for listing the congruent sides, oh, I just flipped that around, dang it. Okay, just draw an arrow. Okay, so for congruent angles, I'm going to draw in my congruent symbols here. Alright, so H goes to angle L, I to angle M, angle J to angle N, and angle K to angle O. Alright, for letter B, this one, it says if triangle WXY is congruent to triangle HJI, complete each part. So again, here's our congruent statement. Okay, I know that W is the same as H. Okay, now look, if H is 37, then this has to be 37. So I'm going to go fill that in. Okay. Then we have X, and that is congruent to J. And if that is 114, then this is 114. All right, and then I is comparable to W. Sorry, Y is comparable to I. All right, well, they don't have an amount or a degree measurement, so I'm going to have to go ahead and add 114 and 37 together and then subtract that from 180. And get, that is 29 degrees, since these are congruent. Okay, now we have to list our sides. So JI is congruent to XY. So here's JI, here is XY, it says that this is 16. Okay, for JH, that would be XW, and that would be 15. Okay. For example 2, using congruent parts, the wings of the SR-71 Blackbird aircraft suggest congruent triangles. So down here in this picture here, what is the measure of angle D? Okay, so it looks like C and F are the same at 75. Okay, so 75 plus 30 gives me a 105. And if I subtract that from the 180, I get 75 degrees. Okay, so it looks like B is my solution.